Hello 10th class students. Today we are discussing our chapter number 4 in science. The name of the chapter is metals and non-metals, and we will discuss a topic in this chapter, that is the chemical properties of the metal. In previous video we have discussed about the physical properties of the metal, that their color, their sonorous property, their ductility, etc. And in this video students we will discuss the chemical properties of the metals, that how the metals react with the different components in order to produce the products. So students, let's just start the chapter. If we talk about the chemical properties of the metal, then the very first property that comes in our mind, that how metals reacts with oxygen. Nearly all metals students reacts with the oxygen and they produces their oxides. We have seen that the metallic oxides are basic in nature and the oxides of the non-metals are acidic in nature. So let's see some reactions, how some metals reacts with the oxygen and produces their oxide. If we talk about the copper readily reacts with oxygen in order to produce copper oxide CuO. If we balance this reaction, 2 oxygen and 2 coppers are there. So this cuprous oxide or copper second oxide is basic in nature. This is the first property of the metal, that whenever the metals reacts with oxygen, they produces metallic oxide, and metallic oxide are basic in nature. Second thing is students, let's see another reaction when aluminium reacts with oxygen. Then it will produces aluminium oxide, Al2O3. The formula of aluminium oxide is Al2O3. If we balance this reaction, 2 aluminium here, 2 aluminium and 2 oxygen, 3 oxygen. So 2 here, 4 aluminium. So we will make it here 4 aluminiums are there. This reaction is balanced. So in this way students, the metals reacts with oxygen and produces metallic oxide. Let's see the second property, but before seeing the second property, let's see one important terms related to the aluminium oxidation, a term known as anodization or anodizing. Anodizing or anodization is a method of producing a layer of the aluminium oxide on its surface. Actually students, anodizing is the method of corrosion of the surface of the aluminium. We have studied about the corrosion, that whenever the unwanted layer of the oxide, sulfide, etc. are produces on the surface of the metal, then we call it corrosion. Here when aluminium reacts with oxygen, it produces aluminium oxide, which is unusable product at the surface of the aluminium. But students, the corrosion of the surface of the aluminium is somehow useful for us in order to make the beautiful aluminium articles. So students, in anodizing process, the aluminium articles is electrolyzed with the help of sulfuric acid, that is H2SO4, and aluminium article is placed at the place of the anode, and cathode is made up of some other metal. So whenever the electricity is passed through the electrolytic solution, then oxygen liberated at the surface of the aluminium, which radically react with the aluminium surface itself and make the aluminium oxide, that is Al2O3. By anodizing process, the surface of the aluminium, suppose this is an aluminium article, and here this surface gets anodized in the form of aluminium oxide. So students, this surface will protect the further corrosion of the aluminium inside the bulk of the article. Second important of this anodizing is that this corroded surface of the aluminium oxide can easily be colored with the beautiful color. As you know that the surface of the aluminium cannot easily be colored, but this surface of the aluminium oxide can easily colored with the help of other different types of the color. So we can easily color the surface of the aluminium article, as well as we can prevent the further corrosion of the aluminium inside the bulk of the article. So this is the importance of the anodizing, and in the process of anodizing, sulfuric acid is used and aluminium article is placed at the place of the anode. That is why this process is known as anodization of the aluminium. Second property of the metal is students, reaction of the metals with water. Reaction with water. So students, most of the metals readily react with water and they produces their hydroxide along with the production of the hydrogen gas. Let's see some reaction how different metals react with water. First we see the reaction of the sodium. When sodium, that is Na, reacts with H2O, it produces NaOH and H2 gas is liberated. If you balance this reaction, then see hydrogen 3, 2Na and hydrogen again, 2 oxygen, 2 to the 4, 2 and 4 hydrogen. In this way students, we see that when metal, that is sodium, reacts with water H2O, it produces NaOH, which is a base of the metal, hydroxide of the metal, and hydrogen gas is liberated. Let's see the second reaction, a reaction with potassium. The same reaction takes place with the potassium, that is K plus H2O gives to KOH, and it also produces H2O. If you balance this reaction, so 2 and 2 K, 2 to the 4 hydrogen, 2 and 4 hydrogen, 2 oxygen. So it will not, H2O, it will only hydrogen. Hydrogen gas is liberated. So in this way, the metals readily react with water in order to produce the related base and along with the liberation of the hydrogen. Let's see the next important property of the metal, and it is the most important property, that a reaction of the metals with acid. Reaction of metals with acids. So students, nearly all metals react with acid and they generally liberate the hydrogen gas. There is a case in which hydrogen gas does not liberate it, but in most of the cases the metals react with acid, different acids, and they produces the hydrogen gas. Let's see some reaction of the acid metals with acid. First of all, we see the reaction of zinc with an acid, that is H2SO4. Then we see that zinc sulfate ZnSO4 is produced and H2 hydrogen gas is liberated. But students, remember that whenever the nitric acid that is HNO3. Whenever nitric acid reacts with the metals, it does not produces or does not liberate the hydrogen gas, but instead it produces some nitrogen compound along with the production of the water. Now, we see what is the reason behind this. That all metals react with other acids to produce hydrogen, but nitric acid when reacts with metals does not produce hydrogen. The reason behind this, student, is that nitric acid is a strong oxidizing agent. Remember, strong oxidizing agent. And due course of this property, whenever the hydrogen is produced in the reaction, it oxidizes the hydrogen. It forms the water. The oxygen easily gets combined with hydrogen and it produces water. Let's see a reaction. When this zinc reacts with HNO3, HNO3 is the chemical formula of nitric acid. Then it produces, it gives Zn NO3 whole twice plus H2. If we balance this reaction, then 5 12 nitric acid and here again 5 ZnNO3 whole twice. So in this reaction, you see, students, that instead of production of the hydrogen, production of the water is taking place along with the production of nitrogen gas also. Nitrogen gas is also released. This is the hydrogen gas is not producing here in this reaction. The reason behind this the strong oxidizing property of the nitric acid. Okay, students, let's see another important topic. Another property of the acids that easily reacts with the metals, but some metals like gold, platinum, which are negligibly reactable metals, or which are the least reactive metal. Actually, gold and platinum does not normally react with other acid and bases to form the compound because these are the least reactive metals. That is the reason behind making the ornaments by the gold. All the jewelries, ornaments are made up of gold because you have seen that the shining luster of the gold does not change with the time. But if you want to dissolve the platinum or gold in acid, then normally they does not dissolve, they does not react with any type of acid. But there is a special type of combination of the acid, we call it aquaresia. Aquaresia is students actually not a single acid, but it is the combination of the acid. Normally, acids that we use are mainly of two types. Any acid can be concentrated or diluted. Concentrated, that means it's a strong form or the purest form, which is very strong. But when we add some water in it or other compounds, then the strength of the acid, the power of the acid get diminished. So we call it dilute acid. But whenever the concentrated acid, two concentrated acids, that is HCl plus HNO3, that is nitric acid, hydrochloric acid and nitric acid, concentrated, which types of it? They are formed or concentrated. Concentrated hydrochloric acid and nitric acid are combined together in the ratio 3:1. That means 3 part of the hydrochloric acid and 1 part of the nitric acid mixed together. Then this mixture or this solution is known as aquaresia. And students, you will be surprised by knowing that this aquaresia can dissolve gold and platinum metal in it. It can react with gold and platinum metal. But neither hydrochloric acid nor nitric acid, they cannot separately react with these metals. But whenever they combine together, they can easily react with the gold metal as well as platinum metals, which are the least reactive ones. So that means their power gets increased. And the solution of the hydrochloric acid and nitric acid, concentrated hydrochloric and concentrated nitric acid in the ratio of 3:1 is known as aquaresia. And aquaresia is the strongest acid known till date, which can dissolve the least reactive metals. Okay students, so this is the definition of the aquaresia. That aquaresia is the combination of the concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. Let's see students another property of the metals. Fourth property of the metal is students when metal reacts with other metal salt. Metal salt like sodium chloride, it may be copper sulfate. Okay, so a reaction of one metal with salt of other metal. Let's understand this point with the help of a chemical reaction. We have somehow discussed this point in our first chapter, that is chemical reaction and chemical equation. Let's see if iron Fe reacts with CuSO4 copper sulfate. Copper sulfate is the salt of copper with sulfate ion. Iron is a metal, copper is a metal, but copper is present in the form of salt. So whenever this type of reaction takes place, that one metal reacts with the salt of the other metal, then here FeSO4 plus Cu1 comes. Now we recall students that this reaction is of substitution reaction, or we can say displacement reaction. That means the iron is displacing the Cu. Iron is taking the place of copper and it getting combined with sulfur here, displacing the copper. That is why this reaction is known as displacement reaction. Now see students, how one element can displace the other element, or which metal will displace and which metal will get displaced. In order to understand this thing, that which metal will displace which metal and which metal will get displaced, we have one term, that is reactivity. The metal which is more reactive will displace the least reactive. In this case, iron is more reactive than copper. That is why iron can replace the copper. Iron can displace the copper. But if this reaction we consider that when Cu is reacting with FeSO4, then it will produce Fe plus CuSO4. This reaction is not feasible. This reaction will not take place because copper does not have power to displace the iron. The reason behind this is that students, copper is less reactive than the iron. Copper is less reactive. So, in order to understand that which metal is more reactive and which one is least reactive, we have the reactivity series. The reactivity series of the metal, the series in which the metals are arranged in the form of their reactivity. So, it will be more convenient for us in order to understand that which metal can be replaced by other metal, which metal will replace that metal, and which metal cannot replace that metal. So let's understand, or let's see the reactivity series. So students, the reactivity series is nothing but list of the metals in which the metals are arranged in the form of their reactivity, or in the manner of their increasing order of reactivity. So students, see here that potassium, K, sodium, Na, calcium, Ca, magnesium, Mg, aluminium, Al, zinc, Zn, iron, Fe, lead, Pb, and here it is hydrogen. Below the hydrogen, copper, Cu, mercury, Hg, silver, Ag, and gold, Au. So students, here you see that this is the series, reactivity series of the metals, but hydrogen is a non-metal in this series. Hydrogen is actually a standard taken here, and all the reactivity are compared with hydrogen. That these four metals are least reactive than hydrogen, and these metals are more reactive than hydrogen. And if we compare the reactivity of the metals among them, then potassium is the highest reactive metal and gold, Au, is the least reactive metal. So by knowing this reactivity series, we can say that in displacement reaction, which metal will displace the other metal and which metal will get displaced. If we see that calcium can displace magnesium, aluminium, zinc, iron, all these metals can be displaced by calcium, but calcium cannot displace sodium and potassium. Why? Because sodium and potassium are more reactive than calcium. Here if you see copper can displace mercury, silver and gold, but copper cannot displace these metals. As we have discussed in a reaction before, that iron can displace the copper, but copper cannot displace iron. Now, this is the reason that in reactivity series, iron is more reactive than the copper. That is why copper cannot displace the more reactive metal. So students, this is the reactivity series according to the increasing order of the reactivity of the metals.